Lesson 1, Roots and Radical Expressions. At the end of this, you'll be able to find the nth root of a number or an expression. Some of this is taken from Henrico County's PowerPoints. Some of it is stuff that I've added, so it's a little bit of a mixture, but I just wanted to give a shout out to Henrico County. All right, definition of the nth root. For any real numbers a and b, and any positive integers n, if a to the n equals b, then a is the nth root of b. That's just a definition. Now, understand that for the square root, the value of n is 2. Anything else is called cubed root, fourth root, fifth root, etc. So it's pretty easy to figure out what the n is. Now, notation, very important. We have the index. That's this little guy here, the 4. He's kind of inside of the little check mark part of the radical. The radical is this check mark symbol. This bar here is actually called the inclusion bar because it goes out and it goes over everything that's included in the radical. And then the radicand, that is the number inside or under the radical. The radicand could actually be variables too. Now, it should be noted that an index of 2 is understood but not written in a square root sign. Okay, so it's understood, but we don't write it. If we want to simplify the fourth root of 81, to simplify means to find x in the equation x raised to the fourth power is equal to 81. And simplest radical form means that there's nothing left under the radical that has a perfect root. So the solution to the fourth root of 81 is 3, because 3 to the fourth power is equal to 81. Now, principal root, the non-negative root of a number. We really only have to worry about principal roots with even indices. If you've got an odd index, you only have one root. But if you have an even index, square root, fourth root, sixth root, you could have a positive or a negative, or you actually have a positive and a negative. You, as the human, must determine what is important and what works. So if you just have the square root of 64, think positive, principal square root. It's understood without a sign there that we're talking positive. Now, if we put a negative symbol in front, we have the opposite of principal square root, or the negative root. Plus, minus, both square roots. You could put a plus in front. That won't change anything, but typically, just like with numbers, if it's the positive root, we don't put any sign. Now, this is important because here, if the radical already exists in a problem you're given, you give the root based on what the radical is asking for. So, plus or minus the square root 169x to the fourth. All right? That means I want to find the fourth root of something. So, but fourth root, square root. There is no index. Notice no indexes here. It's understood to be 2. Okay? So I want the square root of 169x to the fourth. I can think about that as taking the square root of the number, which is 13, and the square root of x to the fourth. Any variable, the square root of any variable raised x to the n is equal to x to the n divided by 2 when n is even. If n is odd, okay, then you would have x to the n divided by 2 square root of x, and you would take just the whole number. Okay, you wouldn't take the remainder. We'll look at that a little bit more. So here I can think about 169x to the fourth as 13x squared, which means that I have an answer of just plus or minus 13x squared. You can rewrite something as something squared to figure out square root. Now, for this next one, notice I have a negative out front. So now I know that my answer is going to be the negative root. But I have 8x minus 3 raised to the 4th power. Please don't multiply this out. Okay? Think about it like this. Okay? We're going to let a equal 8x minus 3. So now I have negative square root of a to the 4th. This would be negative a squared. Remember, this is understood to be negative 1 times a squared. Now I can say that this is equal to negative 8x minus 3 quantity squared. Do it that way. Please don't multiply the whole thing out. It would be crazy. Okay? You can also rewrite it like this. Now, here are some cubed roots. Rewrite it as something cubed. 125, x to the 6th. Again, anytime you're doing this, you've got the index and the power. So 6 divided by 3. That's how you figure out what comes out. So we have the cube root of 5x squared cubed, which gives you 5x squared. The 6 divided by 3, that's that 2. The cube root of 125 is 5. You should learn the perfect cubes 1 through 6 or 7, and then you should know that 10 cubed is 1,000. Okay? Down here, again, you can rewrite it as something cubed. So I've got the cube root of negative mn quantity cubed. Remember that negative 1 cubed is still negative 1. So now you get the cube root, and notice that this is negative mn. But there's no negative in front of the radical. That's okay. If it's an odd root, then it's either a positive, or if it's an odd index, then the root is the same sign as whatever is underneath the radical. Okay? Now, taking the nth roots of variable expressions using absolute value signs. This is importante, important. If the index n of the radical is even, the power under the radical sign is even, and the resulting power is odd, then we must rewrite it using an absolute value sign. Sounds like a mouthful, and it sounds very confusing. Let's take a closer look. Here, I have the 4th root of an raised to the 4th. If I just take the 4th root of an raised to the 4th, I get an. Now, I've got to do my test. Do I have an even index? Check. Do I have an even power inside, even inside? Check. When it comes out, the power is odd. Check. Therefore, I need absolute values. An easy way to remember this is E, I, O. Even, index, even, inside, odd, out. And this is the even index. The power is even on the inside and odd on the outside. Here, notice that it's just based on the variable. The 6th root of xy squared to the 6th is just xy. Index is even. Inside, they're both even. This is x to the 6th, x to the 12th. But when they come out, y is squared, but x is still understood to be to the 1st power, which is odd. So we only put the absolute values around the x. Now, why did I do this? Why am I telling you this? Just to make it hard? Just to trip you up? No. The absolute value signs are used to clarify the answer, because the problem indicates that the principal, or positive square root, is the desired result. The absolute value signs ensure that the answer is positive. It says inside here, x raised to the 6th power is always going to be positive. But if x is a negative number and I raise it to the 6th power, I still have a positive number, but this would be negative out here, and that would not give me the principal root. It's to make sure that I get the answer that I'm looking for. Now, here, again, even index, and this is because, remember, we think about it as a 2. And then we've got the radical. It's even inside. It's odd out. Absolute values. Even index, even inside, odd out. Now, in this particular case, you could do the 3 minus y quantity squared cubed out here or on the outside. You cannot distribute the 18. No, 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 no. And please do not FOIL this out. Again, think about this as let a equal 3 minus y. Then I have the 6th root of a to the 18th. That means I have a to the 18 divided by 6 is a cubed. Boom. I put it, since it was even index, even inside, odd out, I need absolute values. What is a? A is 3 minus y squared, and then I have the cubed. Okay, careful, the expression is raised to the 18th power. Remember, when you've got the radical, you can't split up adding and subtracting. Okay, simplify, use the law of exponents to rewrite the expression as something to the 6th power. Why no absolute value when the index is odd? Well, think about it. When the index is odd, there is only one possible root. The cubic root of 8 is only 2. Negative 2 is the cubic root of negative 8. There is no need for absolute value because there's no possibility for confusion about which root you want or which root you're given. So remember, Old MacDonald had a variable, E-I-E-I-O, even index, even inside, odd outside. Then use absolute value on variable. Just remember Old MacDonald. In summary, you have the index, you have the radicand, and you have the radical with the inclusion bar. Over here on the left-hand side are the rules, the exponent rules that you should recall, should know, should remember from Algebra 1. Those were part of Algebra 1, and you are expected to retain that knowledge. I have it all written here so that if you're struggling with it a little bit or you forgot some of it, it's right there on the left. When you multiply like bases, you add the exponents. When you divide like bases, you subtract the exponents. When you raise a variable or when you raise a power to a power, you multiply the exponents. A negative exponent means you take the reciprocal of the number or the variable. Any number or variable to the first power is just that number. Any number or variable to the 0 power is equal to 1. When taking an even root, absolute values must be used around any variable that has an odd exponent when outside the radical. B to the 4th will always be even, so there's no absolute value needed in this example. That's it.